So when you shine light onto a molecule, it absorbs that energy, and then the colour of light that it gives off again, the frequency of that light will tell you what kind of molecule you're looking at. So basically what we're doing for our research is trapping molecules in like very small nano mirrors.
We're currently collaborating with an NHS hospital, and what they want to do is screen people for a disease called conjunctivitis by looking at tear samples. So effectively what you're doing is looking for small numbers of molecules in a large background. And to do this for a large number of people, you want to do a lot of measurements very quickly and very cheaply. And so our technique has the advantage that it is both very quick and very cheap.
Which of this one match the one you've seen? Excellent, that's fantastic, yeah. So for example, they can use it in the airport for security to check what...
We start with, plastic spheres, tiny plastic spheres suspended in water, and we use a technique called self-assembly to assemble them on the top of conducting substrate, and then we deposit metal or any other materials in between the spheres and then dissolve the spheres, end up with, cheap and easy method to make this material.
And effectively what our surfaces look like are patterns of nanoscale mirrors, and these trap light in the same way that a regular mirror does. And the trapping of the light gives you very strong electric fields. We can then use these electric fields for doing interesting measurements. In particular, what we like to do is to put molecules into those electric fields to excite the molecule. The molecule will then give off a signal, which we can tell from the signal that we get what kind of molecule we're putting there. So it's a very useful diagnostic kind of technique. This work requires a number of disciplines. We need physicists to understand what kind of fields are happening inside a nanocavity. We need a chemist to understand how best to put a molecule onto a nanosurface. And we need a biologist who will understand a bit about the molecules themselves, tell us which ones are interesting and why we should look at them.